Now we're going to calculate cosine of 15 degrees in somewhat different way from the way we did it before. This way is, well, definitely more complicated. And obvious question is, well, why should we do this? We already have a nice, easy way to calculate cosine 15 degrees, what this thing is about. And the reason why I want to do it this way is to, well, not really just to show some different formulas in trigonometry or how to do different things in trigonometry, but also show some additional techniques that could be used in algebra in general. So a lot of things we're going to talk about today is about algebra, not necessarily about trigonometry. So let's move on. So we start with one of the formulas we got previously for cosine of 2x. It's 2 times cosine square x minus 1. We got it before. And here we're going to take 15 degrees as x. In this case, 2x becomes 30 degrees. Now, we know that cosine of 30 degrees is square root of 3 over 2. So let's put it in. And now we basically have a quadratic equation for cosine of 15 degrees that we want to solve. So we have minus 1 on the left. We want to get rid of it. So we add 1 to both sides, left and right side. And then we have 2 sitting here in front of cosine square. So we divide by 2 both parts of the equation. This is what we're going to get. So now we have something squared equals square root of 3 plus 2 over 4. Well, the solution, as you would normally do, you would say, well, in this case, what are we looking for is plus or minus of square root of 3 plus 2 over 4. Now, if it was a regular quadratic equation, this is our answer. This would be our answer. In fact, there would be 2 answers. One is plus sign, one is minus sign. But we are talking here at specific thing. We're talking about a cosine of 15 degrees. Well, 15 degrees lays in first quadrant between 0 and 90 degrees. In that quadrant, if you remember, both sine and cosine are positive, and because of that, we have to keep plus sign and throw away minus sign. Okay? This is our answer. So we can kind of simplify it a little bit. Square root of the fraction is square root of numerator. This is what you have here, divided by square root of denominator. Square root of 4 is 2. And that will be, or could be, the final answer. Now here you could say, well, wait a second. This is not the answer we got last time when we calculated cosine of 15 degrees. In fact, we got something else. We got something like this. Okay. How's it possible? Okay. Different formulas, but seems to be both showing that it's cosine of 15 degrees. Now you can do a quick check, put both formulas in calculator, and guess what? The calculator will going to give you the same answer. So in fact, both formulas are 2 representations of the same number. Well, that's kind of well, it's fine on one hand. On the other hand, it's kind of unsettling, because if I look at this formula, how would I know that it's the same as this? Unless I put something in calculator. Even if you put in calculator, calculator gives you finite accuracy. Okay, it doesn't give you. It's not going to give you exact answer. So you're going to say that, well, these numbers match, up to the accuracy of calculator. But is it really absolutely the same number written here and here? Well, what we're going to do next is we're actually going to do some math. And we're going to go and show that what's written here on the top is absolutely the same as what's written at the bottom. Okay, let's do that. And it's really the main purpose of this video actually. So really this division by 2 is a simple thing. We don't care about it. So what we care about is the thing on the very top. What we have here is nested square roots. So there is one square root inside of another one. So, and that's what we want to kind of look at. So the solution, or what we would, the idea of the solution would be to find such x and y. So what's written on the square root, namely square root of 3 plus 2, can be represented as x plus y squared. This is what we want to find. And if we are successful in this, well, then what's written here is really absolute value of x plus y. All right? So essentially, what we're saying is we would like to find such x and y. So square root of 3 plus 2 equals x plus y squared. Okay, this part. Now let's open up this parenthesis. If we do, we're going to get this formula. If you're not familiar with this formula, I recommend you to derive it and memorize it. Okay. So, but now what we have, we want what's on the left be equal to what we have on the right. But what we have on the left is two terms. What we have on the right are three terms. So how are we going to deal with this? Well, what we're going to do is we're going to say, well, we want the square root of 3 be the same as 2xy. And we want that 2 to be the sum of x squared plus y squared. That kind of a natural way to split those two things. Okay. All right, so let's rewrite this again. 2xy equals square root of 3, x squared plus y squared equals to 2. Okay? And now we need to solve this system of two equations. We need to find x and y that would satisfy to both of these equations. All right, the way we're going to do it, we're going to solve it. We're going to use the red equation, the first one, to express y via x. And this is what we're going to get. We got it from this equation. And now we're going to substitute this y, or this value for y, into the second equation. And this is what we're going to get. So the next step, obviously, we got one equation, one unknown. The next step is to solve this equation. And let's concentrate on that. This is our equation. Let's get rid of this parenthesis squared. So what's going to happen here is this. So square of the fraction is square of numerator divided by square of denominator. We got the equation like that. What do we do about this? Well, let's get rid of denominator. To get rid of denominator, let's multiply both sides of this equation by 4x squared. Now, this can only be done if x not equal to 0, but since we have x in denominator already, we know that x cannot be 0. Okay? So when we do that, we get an equation like this. Now let's move 8x squared to the left side. To do that, we subtract 8x squared from both parts. This is what we're going to get. And now we got an equation. It's actually an equation of fourth order. But so it's what's something called quadratic equation. But now if you look, in this quadratic equation, we have terms only with x squared and x to the fourth power. We don't have any terms with x or x cubed. So equation like that is called biquadratic equation. And to see what's going on here, we need to notice that x to the fourth is x squared squared. Okay? And now if you look carefully here, you see this is actually a quadratic equation with respect to x squared. To see it better, we can create a new variable t as x squared in our equation. A new variable becomes quadratic equation. Now, quadratic equation is really not that terribly difficult thing to learn how to solve. If you have equation like this, at squared plus bt plus c, where a, b, and c are constants, this equation in general has two solutions for t, and those two solutions could be expressed by this formula. So when we see plus minus, what it means that one solution, let's call it t1, has a plus sign here in front of square root. The other solution, t2, has a minus sign. So two solutions. So now let's apply this formula to our quadratic equation. First of all, let's figure out what a, b, and c are. So we see that a should be 4, b should be minus 8, and c should be 3. Now we plug these values for a, b, c into this formula, and this is what we're going to get. When we simplify everything, we get that t has two values, 1/2 and 3/2. Okay? Now the question is, which one should we choose? Well, in general, if you are to solve this equation, okay, or to solve this equation, somebody asks you to find me all the solutions for all the x that satisfy this equation. That's really what it means to solve this equation. Yes, you would use the both. You say, well, I have a solution when t equals 1/2 and when t equals 3/2. Now, we don't care about all solutions. We just need to have one that give us what we want. So, and let's just take 1/2. Why not? Okay. Okay. And the next thing we need to remember that t is actually x squared. We're looking for x. Okay. But we know so far we found x squared, which is 1/2. So if x squared equals 1/2, x equals plus minus 1 over square root of 2. What plus minus means that there are two solutions really. There are two x that satisfy this condition, that x squared equals to 1/2. One solution is plus, another solution is minus. Okay. Again, if we are interested to solve this equation, we would look for all the solutions possible. Now we're looking for one solution, and let's just take with a plus sign solution, 1 over square root of 2. Okay, let's do that. And let's go back. Now we found one solution. We found one x that satisfies this condition, this equation. That's all we wanted to do here. Focus. Let's go back to our previous slide. This is our equation, which we were solving. We found x, or one of the x's that satisfy this condition. Now remember, there's y can be expressed through x. S squared of 3 over 2x. Well, we can plug our x into this equation, and this is what we're going to get. Okay? So now we found x and y, which we can put in this form. Okay? So let's clean up the picture. We just leave what we need for this. And the next thing to note is that, well, what we found that the square root of 3 plus 2 is equals absolute value of x plus y, and this is x, this is y. Now notice that both x and y are positive, and x plus y in this case is going to be positive. Well, and for positive numbers, absolute value of any positive number is that positive number. So in our case, by choosing x and y, in a nice way, in the right way, we can simply say that x model of x plus y equals x plus y, and we plug those numbers, and this is what we're going to get. So, and as you notice, we went from square root inside of the square root to something that just have one square root. We don't have this nested square roots anymore. Now, the last thing to note is that what we found here is really just a numerator for cosine of 15 degrees. And to find cosine of 15 degrees, we need to divide this numerator by 2. And if we do, we get this formula. And that's exactly the formula we got last time. Okay? So this is it. This is a video that actually, the reason for making this video is just to show you different techniques that you can use in algebra. Although we started this as trigonometry, but really most of the time is spent in simple algebra. So if you know all of it, that's great. If you don't, just follow the video and kind of, look at different things we use. How to solve a system of nonlinear equations, how to solve biquadratic equation, how to solve quadratic equation, and in general, if you have something like nested roots, okay, here's kind of an algorithm how to solve problems like this, because problems like this do happen in different places. All right, that's it.